Hi, I can't begin to tell you guys how much I miss getting to see you face to face. Hopefully you guys are all doing great and we will be able to get back to face learning one of these days before too terribly much longer. But the important thing right now is that you and your families are staying safe and healthy. I realized that starting with lesson 96, we added in some other binomial expansion problems that are going to be way too hard for you guys to do if you use Pascal's triangle. If we have something like x minus 2y to the 57th, that's going to be a real pain to try to use Pascal's triangle and work it down all the way to row 57 and hope that we haven't made any mistakes in adding those terms up to get the coefficients once we have a power that high. So instead I'm going to give you a formula, and this is really a preview of what we would do in lesson 102, but we started adding the problems in now to give you a little bit of extra practice. So here's our formula using combinations to be able to simplify these things. Now whatever our first term is, so if it is an A, the variables with their powers are still going to be the same as they were before. If we're raising the binomial to the nth power, we take the first variable to the nth, and then that goes down to n minus 1, keeps going until we get to the first, and then until we don't have any more of the firsts. And it reverses for the b, the last term in the binomial. We don't have any of the b's in the first term, and then we have 1 and 2, and we keep going until we end up with b to whatever the same power is that we had for the power on the binomial that we were going to raise. Now that also means if we want to figure out just one particular term of that, the top part in the combinations is going to be n every single time. If it is the first term, we have 0 b's, so 1 less than that. The second term had 1 less than that. So we still get the exponent on the second part the same way that we did before. It is still 1 less than the term. All that this n minus r plus 1 means is that these two both still have to add to n, whatever the power is that we're raising. And again, the top number in the combinations is always going to be n, whatever the power is that we are raising the entire binomial to. The bottom term is going to be the same as the exponent on that last variable or that last term, as we will see in some examples of the original binomial. So let's try a couple of examples here so you can see how this works. If I wanted to get the 7th term of m plus k to the 14th, I would know that my combination, since that is m plus k to the 14th power, would have a 14 at the top there. My terms in the original binomial are plus m and plus k, so I have a plus m to a power and a plus k to a power. Since I want the 7th term, this is going to be 7 minus 1, or 6. That goes right there, which means my bottom term in the combination will also be a 6. Then I need for my exponents to add up to 14, since that is the power that I am raising this to, which means that this plus m needs to be raised to the 8th power. So all that's left is for me to simplify what 14 choose 6 is when I am doing combinations, and I need to write out the factorial form. Combinations means 14 factorial over 14 minus 6 factorial gives me 8 factorial. And combinations, remember, we also divide. We have the smaller number, so we also divide by 16 factorial. So that means I have 14, 13, 12, 11, 10, 9, 8 factorial over 8 factorial, 6, 5, 4, 3, 2, 1. The 8, 7, 6, 5, 4, 3, 2, 1 cancel all at once. And then I start looking for other things that I can cancel in there. And let's see, what do I want to do? 6. Let's see, if I do the 4 and the 3, that will get rid of the 12. I can get rid of the 5 and the 10 with a 2 right there. 14 over 2 is going to give me a 7. Sorry about the bell there. 9 over 6, if I divide both of those by 3, I will have a 3 and a 2, and then these 2's cancel. So what does that leave me with? 7, 13, 11, and 3. And everything in the denominator has canceled. And if I punched that in on my calculator, I would have 3003, I believe, and bring down my m to the 8th, k to the 6th on each line here so that my work is complete. Final answer, 3003, m to the 8th, k to the 6th. Of course, you could have put that in on your calculator earlier on. I just wanted to remind us of how the factorials worked with the canceling, but this is a required part in your work every single time. Let's do one more. This time, let's find the 6th term of 3x minus 2y to the 8th. This one is a little bit different because instead of just an a or an x, I have a 3x. And instead of just a b or a y, I have a negative 2 times y. That means that when I do this one, I am going to have the entire first term, 3x to some power, the entire second term, minus 2y to some power. Anytime there's a minus sign, that has to be part of the term that gets raised to that power. Since we are raising this to the 8th power overall, we need an 8 in the top part of our combination notation. Since we want the 6th term, we need to do 6 minus 1. So this minus 2y needs to be raised to the 5th power. These two exponents need to add to 8, since we are raising this to the 8th power, and we have put an 8 in the top of the combination notation. So 5 plus 3 would be 8, so we are going to have 3x cubed. Whatever the exponent is on the last term, so the 5, matches what goes in the bottom of the combination notation. So that means we have 8 factorial over 8 minus 5 is 3 factorial, and then we also have the 5 factorial. This one will also simplify quite nicely without using the calculator on the factorial notation. We will need a calculator before we finish the whole thing. Next we have 3x cubed, which means 3 cubed times x cubed, so 27x cubed. We have negative 2 to the 5th, negative 2y to the 5th power, so negative 2 to the 5th times y to the 5th. A negative to an odd power is still going to be negative. 2 to the 5th is 32, and then of course y to the 5th. If we simplify the factorial, we have 8, 7, 6, 5, 4, 3, 2, 1 over 3, 2, 1 times 5, 4, 3, 2, 1. The 5, 4, 3, 2, 1 cancels. The 3 times 2 cancels with the 6. So we are looking at 56 times 27 times negative 32 times x cubed y to the 5th. So final answer, punch this into the calculator, and we get negative 48,384 x cubed y to the 5th. But I wanted you guys to have the combination notation for some of these, and to realize that if these terms are not just a single variable. You have to take the entire 3x to the power, the entire negative 2y to the power, including that minus sign to figure out whether it is positive or negative. That should let you do the extra problems that we've added in related to terms of binomial expansions.